Hello. Hello and welcome once again. Today we are going to learn LCM and HCF, which stand for lowest common multiple and highest common factor respectively. Confusing as they may sound, but let me tell you, they are really very simple. So let's begin first by understanding what we mean by a factor and what we mean by a multiple. Look at these two numbers, 4 and 6. Multiply these, their product is 24 as you can see. 4 and 6 are factors of 24, and in turn 24 is a multiple of 4 and 6. Just as these other numbers have 24 as their multiple. So all of these numbers are factors of 24. Likewise, all of these numbers are factors of the number 36. I see some of the numbers in both these lists being common. The biggest or the highest being 12. So the highest common factor or HCF of 24 and 36 is 12. Simple, isn't it? Now let's look at these two numbers, 3 and 5. These are the multiples of 3 and these are multiples of 5. As you can see, unlike factors, the multiples go on and on and on, though not beyond infinity. And voila, there are some common numbers here too. The smallest or the lowest being 15. So the lowest common multiple or LCM of 3 and 5 is 15.
Mr. Roy, but why should we even bother about HCF and LCM?
Good question, Tia. Let us see some practical examples of HCF and LCM in mathematics as well as in real life. Both HCF and LCM are widely used in fractions. While you will learn more about fractions in another session, for now, let me say that HCF is used in simplifying or reducing fractions, and LCM is used in comparison of or operations on fractions. To understand how this concept applies in real life, imagine this situation. Let's suppose there are 18 students in class A and 27 in class B. Each class divides into teams to prepare for an upcoming sports tournament. The winning team from each class plays each other in the final. What would be the biggest possible team size you could divide both these classes into, such that each team has exact same number of students and that no one is left behind? Careful observation would tell you that the answer is 9. Easy. But what if the class A had 204 students and class B had 255 students? What would be the biggest possible team size then? Well, careful observation may not help here. So use highest common factor. The HCF of 204 and 255 is 51. So the team would be 51 students each. Let's take another real life example. Tom takes a coffee break from work every 45 minutes, while Jane breaks every 20 minutes for coffee. They just finished their break. How long before they meet together again for their breaks? Well, the answer lies in the lowest common multiple. The LCM of 45 and 20 is 180, which means they meet after 3 hours. Hope this helped you, Tia.
Yes, Mr. Roy, it did indeed. Thank you.
Hey there! In our previous class, we had covered fundamentals of HCF and LCM and had seen how these concepts apply in real life. But do you know the method to calculate or derive HCF or LCM of two or more numbers? Well, this is what Sam here also wants to understand too. We shall soon know the answer, but not before my daily jog.
Mr. Roy, I will meet you in the class.
Now that Sam is here, we are ready to begin. In today's class, we are going to learn prime factorization method or the prime factor method to derive HCF and LCM of two or more numbers. The rule to remember in this method is that any number can be expressed as product of primes.
Can you explain this, Mr. Roy?
Sure, Sam. Let me explain through an example. Let's look at a number, say 56. It can be expressed as a product of any two factors. Say 2 times 28. Now 2 is a prime number, 28 isn't. Now 28 can be expressed as 2 times 14. We get another 2 as prime number here. And 14 is 2 times 7, and both 2 and 7 are prime numbers. As 56 can no longer be broken or factorized further, we can write it as product of its prime factors. So 56 is 2 times 2 times 2 times 7. And all of these are prime numbers. Now kids, give me two numbers. It could be more than 2 as well, but let's keep things simple today. With those two numbers, I will show you how to derive HCF and LCM through the prime factorization method.
36
And 48.
Alright, 36 and 48 it is then. Let's start with highest common factor or HCF. First, HCF. First, write down both these numbers as product of their prime factors, just as we did for the number 56 earlier. Now, find the common factors from both these sets. Let's see. We have a common 3 here, a 2 which is common as well, and one more 2. Multiply these and we get the HCF of 36 and 48, which is 12. Simple, isn't it? Now let's look at lowest common multiple or LCM and see how it can be derived using the prime factorization method. The first step again is to write 36 and 48 as the product of their prime factors. The next step is to write each factor as many times as there are maximum occurrences in the numbers 36 and 48.
Can you please elaborate, Mr. Roy?
Let me explain. In these prime factors here, we have the numbers 2 and 3. 2 appears twice in the number 36 and 4 times in 48. So we write down 2 4 times. Likewise, 3 appears twice in 36 and only once in 48. So we write down 3 2 times. Now we take these 4 2's and 2 3's. Just multiply all these and we get the LCM of 36 and 48, which is 144. Hope this was useful. Till we meet again, happy learning, and don't forget to subscribe to the channel below. So long, bye bye.